Let's tackle another disordered structure from the Jaca dataset. Disordered structures, and I'm after 05, B05. Here we are. So let's just shortcut the solve again. Just type solve and JLXT gets that very quickly. So we have a structure with is twice the same thing in there, and we can type the word match to verify that they do match, and they do, so that's good. So the atom type assignment is at least consistent. And then we've got a bit of a mess here. I mean, I guess the name gives it away what that is, but let's just refine this a few times, make it anisotropic, add the hydrogens, refine it again. And we are basically done with the main molecule, I think. I mean, those hydrogens and so on, Control M, let's have a look. So there is still quite a lot unassigned and wrong things here, but let's just deal with this thing at the top first. So what is this? Control G shows us that this could be a toluene. So the first thing, how does it toluene? Well, if I delete all of these things, you can see how that looks like a toluene now. So let's first of all make them ice up, because this makes no sense right now if this is all anisotropically refined here. So what we do, we basically look at the toluene as if it was a toluene. We don't want to know about the disorder. And the way to do this is to type part minus C. So this puts this into the special part. It makes a duplicate effectively, so we can now operate on these atoms as if it was just a standard toluene. The next thing we might want to do is put an affix 66 on so nothing can run away, and that should be it. If we refine this, then it refines quite nicely to a toluene. We can double click on this, make it anis, alt backspace, select the previous selection, add, and all being well, this is not refining too badly. Now what's really happening is there is a symmetry equivalent one on top. Oh, what I haven't done, it's in part -1, but I still have the occupancy as 1, so Control M. So this is clearly not the correct thing to do. What we need to do is part -1, 10.5, set the occupancy to 1/2, and now it looks much better, and the R factors come down, and the map will be much cleaner. Okay, so if you right click on this, bonds and angles, you can see this little growing bond, and that's how it really lies. So we have this whole molecule there twice. So there's 1/2 toluene in that structure, and it's sitting across the symmetry element here, and that's what makes it quite difficult to deal with. Fuse gets rid of it. Control G or grow will not grow it, because this is in part -1, and any atoms that are in part -1 do not make bonds to each other. One thing we might want to do here is to reglue these ones to just keep the ADPs sane. As you've seen, they're all right on top of each other, so it's hard for the refinement program to refine one or the other. So you make this one bigger, this one smaller, and so on, and it becomes a complicated system. So you might need some restraint. You might even need some slightly stronger restraints here. Let's make the reglue 0.01, and hopefully this makes it look nicer. The R factor isn't affected very much, because that's just what that is. So Control M still shows a lot of residuals here. So first of all, we haven't finished yet with our weighting scheme and so on. So let's switch the weighting scheme on and see how much that will affect that. So things move a bit. The R factor should change a little bit. It's still not settled. Control R. Let's do that. And let's look at the fops fcalc plot. And there are some really bad outliers here. So bad outliers can really affect what's going on. Now I keep these ones in place for the moment, but let's see what we get and how the residuals are looking after this. Control M. Okay, so first of all, we can see now. You see, we didn't even spot that there were wrong hydrogen atoms because of those strong outliers. So outliers like this are really quite dangerous. So there are no hydrogen atoms on those oxygens. OLX2 added them, but it's incorrect. Yeah, so they shouldn't exist. So we delete them from here. Just do this, delete on the keyboard, and refine that. And so the R factors definitely come down. And now this is starting to look a little bit better, but there is still a lot of green in here. And the reason for this is that there is actually some whole molecule disorder here. It's not the top part, but the bottom part is disordered over 2 positions, potentially, possibly. Whether that's worth modeling or not is a different question, but those peaks are quite high. So this is 1. And it's possible that it may be useful to model this, but then you also go into the area of over modeling this and not really learning any new chemistry. So for now, I'll leave it at this, and thanks for using OLX2.